Hello, in this video, welcome to previous tutorial. Chemistry, we'll be looking at exothermic reactions and endothermic reactions. So before I go anywhere, we need to know what an exothermic reaction is. Exothermic reaction. These are reactions which release heat to the surrounding causing a rise in temperature of the surrounding. So let's say this is water and you've put sodium metal. You know that sodium metal is highly reactive. So once sodium reacts with water, discover that as you are touching this vessel, heat starts to go. It's hot. Okay, the beaker, for example, if it's a beaker, the beaker is hot. Why? Because sodium is closely reacts with water to form sodium hydroxide and hydrogen gas. So as a process, you know that hydrogen gas is also a very reactive gas. So now, what happens here is, that more heat is lost to the surrounding. Let's say this is the surrounding. So heat will be lost to the surrounding. Now what happens when heat is being lost to the surrounding? What do you think is going to happen to the temperature of the vessel? The temperature in a beaker, for example, it will drop. Since it drops, this temperature in the surrounding, it will increase. And the type of reaction that does that is an exothermic reaction. Right? For example, anything that takes out heat is an exothermic. For example, evaporation. So like I was saying, one of them is condensation reaction. Condensation reaction, because it's a change from it's a change from gas to liquid. Here the particles are far away from each other, or here the particles are closer from each other. So to bring about the closeness of the particles, also what happens? This gas has to lose heat so that the particles can become closer together. What else is an example? Is freezing. You know that freezing is a change from liquid to solid. What happens here? The particles are also not far, but they are mere apart from each other. Or solid, they are closely packed to each other, that they only vibrate about a fixed position. So to bring about this arrangement of particles in a solid, a liquid must lose heat to the surrounding so that the particles can come together. Now, let's look at endothermic. Endothermic reaction is just the opposite of exothermic. Now these, they absorb heat. They absorb heat from the surrounding. Now when this absorbs heat from the surrounding, what happens? Let me give an example. Let's say this is ethanol. Let's say this is ethanol at a very low temperature, okay? And the surrounding is of a very high temperature. All right, so the surrounding has a very high temperature, so it would tend to absorb heat from the surrounding. Once that does, the temperature from the surrounding decreases, and the temperature in this vessel increases. When that happens, once heat is absorbed, there's breaking of bonds in the atoms. Now, examples of such reactions are one, melting. We know that melting, they change from solid to liquid. So for this to change from solid to liquid, what must happen? A solid must be heated. Heat is required. So a solid is going to absorb heat. Once the solid absorbs heat, the particles now become less close together. Evaporation. There are a lot of exothermic reactions, there are a lot of endothermic reactions. I'm just giving examples of those reactions that you know. Okay. So evaporation, you know that is liquid to gas. So these particles are closer together. So to bring about a more separation of the particles, so the liquid must have heat to break those bonds, so that the particles now can become very far away from each other and they'll be moving freely, like molecules. So that's just a summary about exothermic and endothermic. I'll see you in the next video.